This video is about the distance and midpoint formulas.
Let's start with an example of finding a midpoint. So here we have a red segment that connects the point E to the point F, and you're trying to find the location of the midpoint, which we'll usually call M, and it's the point that is directly in the middle of these two. So if you were to measure that distance and cut it in half, where would the location of that point be? If you just use common sense, you can sort of figure it out. If you think about F being located at 2 units away from 0, and I'm just talking about the x value, and E is located at 7 units away from 0, and that's just the x value again. If you think about trying to find the x value that's right in the middle of those, you can just count it, right? So 2, 3, 4, 5, 6, 7. It seems like either 4 or 5 is going to sort of be in the middle of those two. So if you think about going exactly halfway between them, at 4.5, you'll be directly in between the x values of E and F. And then similarly, you want to find what's the direct center middle of the two y values, which is going to be the -4 and the +5. So if your -4 means you're 4 below 0, +5 means 5 above 0, you would be a half a unit above 0. You're halfway in between these. So we're looking at the point 4.5 as x and 0.5 as y, which is going to be located about here, and that'll be the point M. So 4.5 and 0.5. To show that algebraically, so you're not doing guess and check and counting on your fingers and trying to figure it out, you could just find an average, because that's really all those 2 points are. The x here and y here are just the average x value, the average y value from E and F. So an average means add the two numbers together, so the two x values, and then divide it by 2. So 2 plus 7 is 9, and 9 divided by 2 is 4.5. And then same thing for the y values. Add the two y values together, and then divide them by 2. And once you figured out the average of the x's and the average of the y, put them together, and you have the midpoint M. So to see the formula written out, it actually makes it seem a little bit more confusing. But if you just think about them as an average, that's the easiest way to find the midpoint. Here's the formula written out. If you have a point A and a point B, and you refer to them as x1, y1, x2, y2, you can find the midpoint coordinates by doing x plus x divided by 2 and y plus y divided by 2. So exactly what we just did with numbers. Add them together, divide by 2, you're finding the average x and the average y. Now distance is quite a bit more complicated. Distance is a length. It's actually a unit of measure, like I could say, how long is this pencil? It's 4.5 inches. It's a length. When you're finding lengths on the coordinate plane, it's a little bit more complicated. So here's an example. We're going to find the distance between some point U and some point B, and it says it there what the coordinates are. So I have this interactive graph here, and I'm going to type in this U point and this V point so we can see where they are. So if I go to the coordinate, -7, 5. So -7 is over here, +5, we go up to 5, we plot the point. There it is. And I want to plot the point at 4, -3 as well. So I'm going to go to 4 on the x, -3 on the y, and plot my point. So now I've got these 2 points labeled, and they're actually labeled with the x and y coordinates right on the graph. And then I'm going to connect them with a line. So I'm looking for the length of the segment that exists between these 2 points, U and B. So just the length of the segment that goes from here to here. Now I know the line that it just graphed goes on beyond those 2 points, but we're just looking for the length of the segment there. And it's not going to be a nice whole number, necessarily, because it's on a slant. So it's not like I can just count the number of boxes that it covers. But what I can do is imagine that this is a triangle. If I can count this distance, direct vertical distance, and I can count this direct horizontal distance, and I can count how many boxes that covers. So the vertical distance, if it's up at 5 and it's going down to -3, then the distance must be 8. And the horizontal distance starts at -7 and it's going over to +4, so the horizontal distance must be 11. And so you're finding the hypotenuse of a right triangle using something called the Pythagorean theorem, which you may or may not have used before. It's a squared plus b squared equals c squared, where a and b are the two short sides, 8 squared and 11 squared, and it equals the hypotenuse squared. 64 plus 121 5. And C, we're going to take out a calculator and perform the square root of 185, like we said, is not going to be a nice whole number. So, square root of 185, approximately 13.6, is the distance between U and B. What we just used is called the Pythagorean theorem to determine that the distance between these 2 points is 13.6 units, approximately, and it's not an exact number. You could also just leave it as the square root of 185 in radical form. Depends on what the question is asking. If it doesn't ask, it's probably better to do both, or leave it in exact form, which is the square root of 185. Now, you're not usually going to draw a graph to figure out the distance between 2 points. Somebody comes along and turns this into a formula for easy use, so you don't have to do the graph and think about a triangle every time. Because it really is just a formula. It's where did we get this 8, and where did we get this 11? And then how can I just plug them right into the Pythagorean theorem, since that's what we're using every time. So we think about where we got that 8 from. It was from the 2 y values, right? The 5 and the negative 3. And if you think about where we got the 11 from, it was from the 2 x values, the 7, the negative 7, and the 4. So the distance formula, which I'm going to change slides and show you here, incorporates the 2 y values being subtracted, the 2 x values being subtracted. That's where the 8 and the 11 came from. They're both being squared. That's because of a squared plus b squared equals c squared. In the end, of course, we take a large square root over the whole thing, just like in the final step of the Pythagorean theorem, where you take the square root off so you can unsquare the c. So basically, the distance formula, which is up there and it's all written out, is just the Pythagorean theorem in one step. When you're using the distance formula instead of a graph, you want to make sure that you're doing it in the correct order. I don't need to read through it all, but I typed it out here that you want to make sure to do this in the correct order by subtracting and squaring, taking those two results and adding them together, and then the very last thing you're doing is simplifying the square root. Your answer is going to be far off if you try to use a square root anywhere before the final step. So don't try to square root anything and then add together, or then subtract. Square rooting has got to be last. Let's apply it. So we've got a triangle here. Can we find the perimeter of this triangle? We've practiced perimeter before. It means the total length all the way around a shape. And length means distance. Distance means length. So we want to see if we can find our 3 distances. Now, the horizontal and vertical distance is real easy. You can just count them. So this distance here is vertical distance. It's up at 6 and it's down at -2. So they must be 8 away. This horizontal distance, you can just count it as well. It's over at -3. It's a +3, and therefore it must be 6. So far we've got 6 and 8. And it's the diagonal side that we actually need to use our distance formula to calculate. So using our distance formula with the points E and the point G. I'm going to erase some of this stuff that I drew all over here. It's getting confusing. So here's the point G, and here's the point E. And I'm trying to find the distance between them. So the distance formula, I always like to start with the formula, if that's what you're using, is to subtract the x's and square them. Subtract the y's and square them. So we're going to subtract our 2 x values, which is 3 on the top and -3 on the bottom. We're going to subtract our 2 y values, which is 6 on the top and -2 on the bottom. Notice I put minus, knowing that I'm going to change those to plus. I didn't want to skip any steps and have you be confused thinking, where did that plus sign suddenly come from? Because it really is subtraction in there. Okay? Oops. Just skipped a step and added them mentally out of habit. Okay? So here we have 3 plus 3 is 6. And 6 plus 2 is 8. And of course, that's the 6 and the 8 that we counted at the beginning anyway. But in the interest of showing work, I'll continue. Make it a little bit easier to see. We've got 6 squared plus 8 squared. So remember, the order is very important. You square them both, and then the very last thing you do is use the square root sign. You want to square them both, add them together, and the very last thing you do is square root. If you try to square root at this step, you'll end up just doing 6 plus 8, which is 14. And if it was as easy as that, there wouldn't have been a square root in this problem to begin with. It would have just told you to add the 2 numbers together. That's not what it is. Add them together underneath the root sign, then take the square root. So the square root of 100 is 10. And that's the distance here between G and G and E rather. And the very last thing we want to do is get the perimeter of the whole shape, which is what we were asked to find, by doing 6 plus 8, which are the two horizontal and vertical sides, and then 10, which is the diagonal side. So 6, 8, 10 adds up to 24. That's all.